Welcome everybody to this first in our is our season ticket, and the season ticket holders. There are many of you here. This is our innovation, plus many other people who have registered as well. And so it's a real pleasure to welcome Doug Matzke to our platform. And I have just, in fact, reviewed his book for the next issue, so you'll see that. He's very interdisciplinary man, as you'll see from his biography, in terms of his expertise on computation, hyperdimensional mathematics, neurocomputing, quantum computing, real intelligence, and metaphysics. And his book is called Deep Reality, as I say, and you can source that www.deeprealitybook.com, find out more about it. And it's a very groundbreaking book, I think, in terms of the new paradigm, linking our wider and deeper understanding of consciousness with rigorous science on the basis of some really pioneering research, which Doug has been involved in, and also Bill Tiller, who's the co-author of this book. And part of the book is conversations between the two of them. And so I do think that this is groundbreaking material. And I'm sure you'll be fascinated by what Doug has to share with us this evening. So Doug, over to you.
Thanks so much, David and Andrew, for inviting me to this seminar. And hopefully everybody can hear me just fine. I'm going to switch over to the slides here. And then we'll start going through the slides. So this book, Deep Reality, took 5 years for me to write, but I was thinking about it for 20 years. So, but I specifically chose this topic to focus in on the book, the transcendent states, because if you're looking at metaphysics, which this group is interested in metaphysics, right? The transcendent states is sort of like the key thing that says, well, if you can't define transcendent states from something, from some layer, from some mechanism, then you can't really do anything else. You just think of it as hallucinatory, which is what most of the people from the classical physics perspectives think. So my moniker, people call me Quantum Doug because I'm interested in quantum mechanics, and it was easier to spell than my last name is the other thing. So I've been programming for over 50 years. I've been a chairman in the PhysComp 92 and 94. So I've been thinking about this stuff at least 25 years. Where I wanted to tie physics to see if physics would have anything to say about the brain. I've done a lot of papers, a lot of talks, a lot of patents. Very famous paper I wrote in 97 is Will Physical Scalability Sabotage Performance Gains? That was in an IEEE computer science magazine. And so then I graduated, I got a PhD in quantum computing from UTD in 2002. And I built some malloc math tools. And so I use those tools to do a lot of the work that I do. And one of my colleagues that I work with is Mike Manthe. So you might see his name in a bunch of the work that I've been doing as well. And after that, I was awarded an SBIR grant, which is Small Business Innovation Research, that was studying the relationship between neural and quantum computing. So I did this work in Dallas in the mid 2000s. And it basically showed that quantum computing and neural computing are very compatible. And in fact, they both rely on hyperdimensional spaces, which is the basis for this, what I call transcendent space. So I'm also a certified master practitioner in NLP, neuro-linguistic programming, and I've done several, Reiki 2 and several other modalities, energy modalities. And I have a lot of friends who are healers and remote viewers and telepaths and channels and stuff like that. So of course, the reason we're talking today is this book, and the title that we used for the book is Deep Reality, but the label I used for this work is called Source Science. And I talk about it as bit physics, which is physics that's using information theory as the basis for it. So here's the abstract. You've probably already seen that. I'll just flash it up here for a minute, but the key is, how does quantum information support transcendent states, which I believe is the root of all physics. So we're going to kind of just go through these slides relatively quickly, but the transcendent behaviors the key is that transcendent behaviors really do exist. Okay, that's the key thing that we want to do. And all of these are the basis for metaphysics. And so if you look at all of these behaviors here, they don't have anything to do with energy per se. They have more to do with virtual reality and information and those kinds of ideas. So if you look what's going on in the gaming industry and stuff like that, this more looks like gaming technology than it does some kind of physics technology. Okay. And so that's what I'm saying. These behaviors are primarily informational centric. Their awareness, attention, intention, knowing, remembering, there's no energy here at all. So part of the thing I talk about in the book is I try to reset the vocabulary. People use the term subtle energy. And in fact, Bill Tiller came up with that term in the mid-90s as subtle energy is what we kind of use it in the West. But it means prana and chi and ki and mana. All those terms are the other names for subtle energy, but I don't really like the term subtle energy because it focuses on the energy aspects of the phenomena rather than the informational part of the phenomenon. So you'll see that kind of like resetting the language in the book as I go through the book. But the key thing is it's the hyperdimensional bit nature of mind and thought. So there's these behaviors that people have, metaphysical behaviors, that they're beyond classical physics. And in fact, they don't have locality in space and time. So what's the model that allows you to do that? And so that's what I've done is, based on my PhD from 2002, worked on what I call proto bits, quantum bits and entangled bits. And we'll talk a little bit about that, but just realize that's what the book goes into. And if it's too technical for you, just kind of skim those sections in the beginning. I just wanted to just support that in the book was by saying, look, this isn't just wishware. This isn't just making this up. This is real engineering. This is real physics. This is real computer science. And so what you find out is that ultimately the universe is hyperdimensional. And these unintuitive properties, though, of these hyperdimensional space give rise to not only quantum physics, but also transcendence and metaphysics. So Feynman says the world is not classical, damn it, it's quantum mechanical. And so if you believe that, then you go, well, then why isn't the mind quantum mechanical too? Sort of like it's a segue into talking about, well, if all physics isn't classical, it's quantum mechanical, then why about what about the mind also? So they said, what's the primary question we're talking about? And the question is, how does quantum information support transcendent states? Okay. And the solution is it builds on this hyperdimensional bit nature of quantum information. Okay. And you can think of this as related, people may have heard the term simulation theory or simulation model of the universe, right? Well, it's kind of building, it's taking that idea, but actually supporting it in a quantized way, in a concrete way. So, and I call this approach source science. And I use the term source, and then I'm saying, instead of calling it, spirited science or spiritual science, it's too woo-woo sounding. I use the term source, and source is the basis for quantum mechanics, but it's also the source for metaphysics as well. So it's the source of everything that we know. So, so if you look at the beginning of the book, the first chapter, it talks about the foundations, and we say information is physical. Most people don't know this, okay? It's not just mathematical. Wheeler said it's it from bit. He says that black holes are defined as bits too. It's the smallest change that you can make to a black hole is a bit. It's not energy, it's not anything else. And bits are tied to entropy. So that's how this is all related, okay? Also, Rolf Landauer, an IBM fellow who was working in the 61, said, if you erase information, you gotta account for that erasure, otherwise you violate entropy laws. So this was a fundamental effect, and nobody listened to him for 30 years until I had him as my keynote speaker in 92. And so what you have is bits are physical and they have an effective energy and therefore an equivalent mass. So this ties information, energy, and mass together in a way that's consistent with quantum theory, okay? So reality is hyperdimensional. This is the next big thing. Once you learn about bits and qubits and e-bits, you realize that these are very real behaviors and they have essential novel behaviors that you can't get if you have only classical computing, especially qubits and e-bits. So, but if you take a bit as a one-dimensional thing, you can make qubits and e-bits about it. And that was what my dissertation was about. And the qubit is a quantum primitive that has two private dimensions. E-bits is a quantum primitive for entanglement that has 4 private dimensions. And Shor's algorithm takes 2 to the 1,000th of those dimensions, which is a very large number. That's bigger than the number of known molecules in the known universe, entire universe. So you can build fast computing using the exponential nature of the 2 qubits and e-bits, okay? So then finally, thoughts are really quantum things, not in the brain. So kind of defeats Descartes' assumption, which is, that the mind doesn't affect the physical world. And this is a big argument of Tiller. He says that Descartes' assumption is false. It was just an assumption. It's not true. And so you take these thoughts are informational things, and attentions do affect the physical world because matter and energy and information are all related. And there's a whole bunch of research that supports this. And so I like to think about this t-shirt slogan that says, quantum mechanics is the dreams that stuff is made of. Think of it as if there's a God and he wanted to create the universe, what is the best thing to create it with is things that didn't have any previous existence. And these bits represent that, okay? So that's why I say quantum mechanics is the dreams that stuff is made of, okay? So this group here knows about metaphysics behavior. And so I'm kind of like showing you all of these behavior matrix kind of like categorized by the kind of phenomena that it is and whether it affects information, space, time, or energy, okay? So, so awareness, we know about clairvoyance, clairaudience, clairsentience, remote staring, presentience. All of these things are about awareness, right? And perception, you can have remote viewing, you can have the Anu, which is the occult chemistry stuff, medical intuition, muscle testing, precognitive dreams, presentience. All of these things are related to, categorized by space or time or, about what I would call the information metaphor that they're using, okay? Knowing, to me, this is a big thing that how do we know? How do we have meaning? Those are an information paradox. I mean, and I use the term real intelligence to talk about some of these things because, how do we know anything? Computers don't know anything. They just have these bits and they're moving them around like a shell game, but they don't actually know anything and they don't have any true meaning in anywhere. So that's part of my story. So you'll see more about that in the book. And then of course the PK effects. This is the big one. It says, well, you can remote view, you can do all this other stuff, but if you can actually affect the physical world, and there's tons of examples of this, and I'll give you a couple more later on here. So most people in this group know about all this stuff already. So I'm not going to spend any more time reviewing these. And I have tons of examples, my personal examples, where these things are that I have, experienced a lot of these experiences. So these behaviors are what I call the hard problem of real intelligence and metaphysics also. And most skeptics ignore this stuff. So they say, well, this page doesn't exist so that we can ignore it. And so that's part of the problem. So with classical physics. So here's the bit physics. I call it the bit physics of thought. Anytime you think about thought, people say, oh, the thoughts are in the brain. It's a neural thing. It's a classical thing. It's sort of the premise of artificial intelligence is that the brain is a classical computer. And so therefore we can go in and we can create another kind of classical computer, like a traditional computer, and do the same thing as we do with thoughts. And I say, not true, because we must have thoughts independent of the brain. Dean Radin showed that. I'll show you a slide in a minute where he has the double slit experiment and also Tiller's intention host device. But we also must be compatible with quantum theories because this Dean Radin's double slit experiment shows that the mind can directly interact with quantum states. Well, that's a fundamental, I say before, Radin should get a Nobel Prize for that because he's the first time that showed that the mind can directly interact with something that's purely quantum. And that's a fundamental kind of research that he did. So once you've kind of made these paradigm requirements, these shifts in paradigm thinking, then all of a sudden you have to say, well, what can you make predictions that you couldn't have with the other systems? Okay. And so ultimately you need these informational requirements. You have to have memory. This is a virtual processing environment. You have to have memory, you have to have processing, you have to have massively parallelism and massively scalable. If you think that this quantum infrastructure is supporting the entire physical universe, because quantum is more fundamental than the classical world, then you have to have something that's scalable and parallelizable to the extent that it simulates the entire physical universe, including all the black holes and the Big Bang and atomic atomic bombs going off and all that kind of stuff. So we must have this kind of informational requirements that's compatible with what we know about physics, okay, including information and entropy theories. But you also have to have these intelligence requirements, because we have to support all levels of intelligence, from DNA to cells to animals to human, and even this concept of what I call infinite intelligence, which comes from the law of attraction. But you can see that people have infinite intelligence kinds of experiences where they have savant behaviors, and they have no different brain matter than they had before some in their life. So all of this stuff requires you to think about all this stuff, especially the informational requirements section there, where you have to do this. And this is the other big one here, is the learning and knowing. Most neural nets think they're learning and knowing, but they really don't. They're just doing a shell game with these weights, okay? And that's not the same. And so ultimately we have to have meaning in different domains. They always say, well, it passed the Turing test. Well, have a Turing test where you're creating new meaning on the fly, and then see a computer keep up with it, because it can't. It can't do this, okay? It only has pre-programmed meaning or patterns that it sees, but it doesn't really know. If you make a chess move in a computer chess game, it doesn't know the meaning of that chess move. It just knows that it can do it, okay? It doesn't even have a label for it necessarily. So these are all these requirements. And, again, a lot of these, the last one is like, well, you can have direct awareness of any star, I put it, anywhere, any when, anything, anywhere, any nowhere, no when, and nothing. So you have to be able to have these transcendent requirements, including lucidity, which is important for lucid dreaming, but also these transcendent states for near-death experience and stuff like that. So all of these requirements say, well, there's some physics, bit physics for thought, and these are some of those requirements. And as an engineer, I like to know the problem I'm solving before I try to solve it, okay? So here's this example I was showing you, John Wheeler's It from Bit. If you throw information or energy or matter into a black hole, all of it gets essentially on the surface area of the black hole. And these surface area is the dimensions of the surface area are bits. In fact, it's considered the entropy. And so the smallest increment you can make to a black hole is a bit. You can't make it, and that's pretty small, 10 to the minus 34 on the side, compared to the size of the black hole, which is 10 solar masses worth of mass. So there's a big difference between this small increment, but this is an important fundamental concept, that information is fundamental to where quantum mechanics, entropy, and information theory and gravity all come together in this surface area. So this is why Wheeler said it from bit. Everything comes from bits. Okay. So for you who might not know about quantum mechanics, I talked about bits, qubits, and e-bits before. Bits are these really what we call heads and tails, classical bits. And you can think of them in a vector mathematics, like I did for my dissertation, as two states, either one pointing up or one pointing down. And you can't have the heads and tails at the same time, because it collapses that state to zero. These two vectors cancel. But the big difference between that and a qubit has two of these vectors, but instead of having them 180 degrees out of phase, they're only 90 degrees out of phase. This is the spin 1/2 model. And these states now can have an angle between them. And this is, Schrodinger's cat. It can be a phase angle, and it's a probability. So this is hard for most people to get. They said, well, it's either heads or tails. No, it's not. It can be heads and tails. The cat can be both alive and dead, okay? So qubits is a primary thing. It creates the superposition concept. And then e-bits creates two of those, two qubits, and they combine in a way where they act like a super. I don't know if you can see my mouse here, but this there has A0 and A1 as the two states of the qubit. And this has A0, B0 as one state and A1, B1 as the other state. And so it looks like a higher dimensional version of a qubit. And this is the representation. But it's both used in regular Hilbert space math, and it's also in the math that I did for my dissertation. So this thing here is the spooky action at a distance. They're separated, but they act as one. And if you measure one, essentially you're defining both of them, because they'll either both be zero or this is a conserved property. They'll either both be zero or they'll both be one. Okay. So this is a big slide, and I'm going through it very quickly, but realize this is the basis for a lot of what I do. And I've given whole other talks where I just talk more about the science behind it And I'm just giving you an overview so you know the vocabulary. And you can go on my website, either quantumdoug.com or the book website, deeprealitybook.com, and you can see other slide talks that I've given that go more into this math and what this means, okay? But the key thing is, if you have Shor's algorithm, in 1994, Shor came to my conference in 94, and he showed that using a quantum algorithm, you can utilize these 2 to the Q states to solve a problem that no classical computer can solve. So this got quantum computing kicked into high gear in 94, and now it's 25 years later, and you can see now billions of dollars have been spent because of Shor's algorithm. So if you don't know about it, it's a little complex and it's kind of mathy, but it basically says no classical computer can solve Shor's algorithm as fast as a quantum algorithm that's running Shor's algorithm. So that's really important to realize that that these are the basis for when we say quantum computing is exponentially more powerful than classical computers. And I would say even that says, look, we would be extinct as humans and as sentient beings if we didn't have quantum computing as the basis for us, because a classical computer cannot solve this stuff. So we're using the exponential power of quantum computing to be smart, to be intelligence, and to add meaning. So, okay. So the next thing we're going to talk about is, remember I did that SBIR contract for $1 million. So what I just showed you here, this is the quantum bits, and there's an exponential number of quantum states here. This will be the beginning of the hyperdimensional space. Well, here's the other side of that. If you pick a point in 3-dimensional space, you create this point here, and then you can just imagine there's 3-dimensional space here. You pick a point. Now pick a point in a 100-dimensional space. It looks just like it, except they have all these other dimensions. So instead of a list of 3 numbers, you have a list of 100 numbers. Okay, and then if you pick a second point and you say compute the distance between those two, this is using regular mathematics, and you can say, well, if you have these 2 points, pick a bunch of points and compute the distance between any 2. What you find is this graph here. You find that the randomness between where you pick the points fades away, and the distance, because there's 100 dimensions, and so all that randomness cancels out in the distance computation, and you find out that there's 2 points that look like they're very far away from each other, and all random points look that far away from each other. In fact, the higher the number of points you have, if you have 1,000 dimensions, the standard deviation is a constant for the number of dimensions that you have. So what you end up with is this, what we call a topological graph like this. You have point P and point Q. Those are those 2 points we just talked about here. And from the midpoint of the space, these 2 both have a standard distance of square root of n over 6. And you can do this using a spreadsheet if you want, but we proved it with Mathematica, that this is true, and it's an exact number, n over 6, and the standard deviation is independent of n. And so you go, well, what is all this, Doug? Well, the point is that the guy who invented this, a guy named Nick Lawrence, he says, well, the brain looks random, so let's go and look at the statistics of randomness. And that's what he did. And so for a big N, so once he was taking the distance between 2 points, when I came and worked for him in early 2000s, I realized that these points are all like equally spaced around the midpoint of the space. So you can think of that midpoint as a radius, and think of all those other points like a sphere. They're not really a sphere, it's a high dimensional tetrahedron, but you can take this standard distance, and what we call a standard distance and a standard radius, and you can realize it produces this probabilistic geometry. And it looks like this. And this is the same math that's used by content addressable memory and sparse distributed coding. And it's also related to what we do for our CDMA and spread spectrum phones. In other words, our phones wouldn't work unless this worked. Okay, and it's just another way of computing these codes that you use for having multiple things interact in a space where they're sharing dimensions. Okay, but you can look at this and you say, oh, this is the mathematics for the law of attraction, where meaning are the address. So again, this is a big concept. I'm giving you a very short summary of where this mathematics comes from. But if you look at this, these 2 points, P and Q, if you look at it, this radius is standard. If you normalize this by r, this is square root of 2, which means any 2 random points, not only are they a constant distance from each other, but they look orthogonal to each other, which means you can use them the way you would matrix math stuff to do concurrency. So the brain is maximally concurrent because it uses this representation that allows you to have orthogonal state vectors for every thought. And this is important when you start applying it, and I talk about that in the book. So again, these are mathematically hard concepts because you've just heard it the first time and you go, what does this have anything to do with anything, Doug? And I tell you, it does. And you just have to say that this quantum computing and neural computing are the same thing. They both have probabilities. They both have phase angles. They both have, and this makes perfect sense if you look at it from the standpoint. You can be, joyful and sad at the same time. Well, how can you be joyful and sad if they're opposites of each other? Or you can be joyful and you're happy sad, right? Well, if each state is its own orthogonal dimension, this big vector here, I call it a thought vector, then you can realize that thought vector is orthogonal to the other one. So you can have a mixture of them. You can also have a mixture of Republican and Democrat. You can have, because they're not opposites. In fact, no two concepts are truly opposites, except if you do it at the single bit level. Okay. So what does this mean? So you have law of attraction, meaning from correlatives. This is correlational algorithms. That's the name and you can get the meaning from this where it's self-normalizing. It's like, quantum mechanics has this thing where it says any two qubits, you have to normalize it by 1. You have to essentially take all of the quantum states and the sum of the squares of them has to equal to 1 because it's the probability. Well, the same thing is true here where this distance metric and standard distance and standard radius models act the same way as the probability of 1. So it's a normalizing factor that's built into the mathematics. And this is true for any hyperdimensional space. So if you have a hyperdimensional space, you have this property because you can't not have it. Okay. And it's self-normalizing by the standard distance and standard radius. Okay. And we can show that it's Boolean complete, Turing complete, plus it's verb noun balanced if you're using geometric algebra. What does that mean? A thought can be a state, but it also can be like a verb. I call it verb noun balanced. If you can affect a room just by being in a state, you're having an effect, even though you're being in a state. And that's what I mean by verb noun balanced. And a regular quantum mechanics mathematics doesn't have that property. So they can't use states as states as actions and actions as states. But in the geometric algebra that I did, I did. This is important. It's kind of like a quantum version of the von Neumann architecture, which says the memory holds both the programs and the state, but it's more than that because your beingness affects everything because it is the verb and the noun at the same time. So as you can see in this picture down here on the bottom here, each one of these big thought vectors, just like the small bit vectors in quantum mechanics, are orthogonal. You can take any pair of those and they look 90 degrees to each other, which means you can mix and match them arbitrarily, okay? And then meaning emerged from this because each one of these points is a mental observer frame. It's kind of like Carlos Castaneda talked about in his book where he talks about it as his assemblage point. Well, assemblage point is this exactly. And so, when I knew about assemblage point, all of a sudden I realized these are assemblage points. And so every thought you have is a point in this high dimensional space. And then you can essentially take a journey through this hyperdimensional space like you would if you were doing out-of-body experiences. And essentially you can travel through this domain. It's just a hyperdimensional version in your dream computer, if you want, dream spaceship, if you want to think about that as a metaphor. So, but also if you start looking at these two things that are very near each other, since all random things are far apart from each other, anything that's near each other is going to look closer to each other than something that's far away. And so what you end up with is with this bullseye perspective. And if you find 2 points that are real near each other, it's highly unlikely by the states of chance. And so if it's highly unlikely by the states of chance, that means there's some information in there, right? And so if you have something way out here, it's just random. And this is what I mean by the self-normalizing. 2 things that are here, they're partially mixed. There's the happy, sad kind of perspective. But something that's like this, it says 2 points that are right near each other means they're dead on and some repeatable process created it. And that's an information. This represents information. Okay. So again, this is where the law of attraction comes from the meaning now, because all of a sudden you have efficient ways of dealing with hyperdimensional spaces, and you get the what we call the bullseye and the vortex from law of attraction shows up directly out of this mathematics. This is a different representation of the bullseye. Okay, so I know we're kind of going through this quick, but I just wanted to give you a quick introduction that says, look, this is the mathematics. When I say hyperdimensional math, this is what I mean: quantum computing and correlations, and what it means. Okay, and so when you take correlations, if you're simulating a high dimensional space, it's not very efficient because it's implemented in 3D. But if you're trying to implement a high dimensional space, you don't have a version of radar or sonar that's what we call the curse of dimensionality. So in the same way that you can't simulate quantum mechanics unless you use a quantum system because of the hyperdimensional spaces, you can't, because of the curse of dimensionality, you can't simulate the law of attraction or correlations unless you have a high dimensional space efficiently, because you don't have things that naturally appear near each other. Okay, so there's a correlative supremacy as well as a quantum supremacy argument based on this high dimensional math. Okay, so you say, okay, well, all this is great, but I thought you were talking about brains. Well, I am, except that intentions and thoughts can be without brains, and so let's learn about that. For example, learning by single cell creatures, you can have single cell creatures where they have no brains or no neurons at all. For example, anticipation of feeding intervals by single cell creatures, right? What are they? The microtubules? That's what some people say, it's microtubules, but they don't have any brain cells. Jellyfish are cell aggregates. So then you start looking at morphogenic fields in DNA as a possible mechanism for all that stuff, okay? And by the way, morphogenic fields in DNA ties into all this as well. So I'm just using this as a sort of like a requirement, and again, more requirements. But you can also directly download of thought forms. For example, in the Akashic records, you can access the dream and dreams. You can do this. I know people who have downloaded directly mathematics were downloaded to them, and people talk about downloads all the time. So what are those? Okay, well, it turns out Robert Monroe talked about this stuff. He called it rotes. His terminology was rotes. And if you're doing a remote viewing, you say, what's at this target destination? And the result comes back as sort of a thought packet, and he called that term a rote. But you can also look at archetypes the same way. They're all kind of structured information in the hyperdimensional space that has meaning. But you can also do it where you're encoding water. If you encode water with love, the patterns in, the spiritual patterns in water, you can see that there's some kind of encoding for this, okay? And we'll talk about this in a minute here with how Tiller's research too. But all of these are elementaries, elementals, which come from hermetics. I worked with subtle energy tapes where we put different subtle energy tapes back in the mid-90s. But you can also do channeling and walk-ins. You have to have a way of talking about these thought forms in a structured way. And so all of these things are related to this. Likewise, near-death experience. So now let's talk about this intention host device, and I'll show you another slide of this in a minute. So Tiller's team invented this intention host device. It's a small device. It looks like a garage door opener, and that's about how big it is and complex it is. But essentially, when you meditate, you can put an intention in there. And when you do that, you can take that, put it in a laboratory, and actually see a result of putting the intention on. This happens to be, I think this is for water. Yep, this is for water. And he basically changed the pH of water up or down by 1 pH, from 7 to 8 or 7 to 6. And he could put the intention in there. And he also found out there was some kind of magnetic effect on it if he put a magnetic field around it. So it says it interacts with magnetic spaces, okay, magnetic fields. So it's not electromagnetic, but it can be influenced by magnetics. So people who are doing healing with magnetics can find this. But he also did it where his research, you can go find it on the Tiller Foundation website. It increases the reaction rate of organic material and living material. You can change inorganic, organic, and living material using intention host device. And there's a ton of research that could be done with this. And he's already done a lot of research on this, okay? So here's the two slides I was leading up to. Intention affects quantum states. Here's Dean Radin's work where he did classic double slit experiment. He put it in an isolated box, and you could say, relax with it and nothing would happen. And if you concentrate on it, it would change the probability amplitudes. And since this was all shielded, it even did it on the web, so it was remote. you can have directly influence a quantum interference in a box that should not be able to be accessible by anywhere. And this worked, he worked at using online volunteers. So this is, if you haven't read this work, go read about it. And I talk about it in the book, but Tiller also did this gas discharge device where he could show people where attention, and he had this essentially a PK device that was an avalanche gas discharge device. And it would put it near threshold, and then putting your attention on it caused the avalanche to occur, which changes the quantum tunneling essentially of that. Okay. So this is, and when he had volunteers looking at this, they could actually see the ACA cords, even though they were in Faraday cages. So these are the kind of research that Tiller did. If you're interested in that, he has a ton of white papers out there, and I also talk about it, significantly in the book, the main research that he did, and we have this conversation about what it means in the book. So there's no possible electromagnetic effects on all of this. It can't be electromagnetics, so it can't be classical physics at all that does this. Okay, so this is like one of the last slides we're talking about now. We're talking about sort of what are the requirements, right, for this. And so we have out of time knowing. Well, how can you know something that's out of time? This violates everything we know about computing and about information. We said remote in distance, but now we're doing remote in time. Well, quantum physics allows consistency versus causality. For example, the Bell entanglement and self-consistency, the delayed choice quantum eraser experiments. You can go in and study this stuff, and I'm just telling you that quantum mechanics is basically self-consistent through time. You can go measure something, and you can affect the result later about something that happens earlier. Okay, but this happens in physiology and in psychology research too. This notion of presentience. The physiology responds to future emotional images, where they take an image, it's high emotional content, and the body starts responding using EEG and EMG kind of measures, even before the image is chosen. And they found this in old psychological research databases. As I'm doing a meta-analysis, they found it in databases they weren't even trying to measure it for. Okay, so this stuff is real, and you can do precognitive. Anybody who has had precognitive dreams or remote viewing, a friend of mine who's a remote viewer, she did a controlled set of studies where they predicted what was going to be in the newspaper for 2 days in the future. And she had high significant correlation results for that. Also, this notion of retrocausation, where your future mind influences your past mind. And essentially, you can tap into your own future knowing. And any student who's ever studied for an exam and then studied after the exam knows that if they do this, they do better on the exam. And this is an example. So if you have kids in school or grandkids in school, have them know that if they study for the exam after they know the questions and they know them really well, they can tap into that knowing when they're taking the exam and do better in the exam. And this major work that was done, I think by his name is Brem, who did this work. And then we have what I call panoramic time and time distortion. If you have an NDE life review, you were kind of looking above time and seeing all time as if it was a river flowing below you. But also NLP timeline therapy does the same thing. Monroe's inspect, which is his future self, guiding his historically older self, younger self. Those are all examples of that. Even Bandler for the NLP, he uses hyperthesia to distort time and space. So these are all examples. I talk about them in the book. I'm just giving you a quick, that time isn't a factor for this, and no classical model can solve it. That's why you have to have a quantum mechanical model. So this is how I try to understand where the temporal model comes from. If you think about consciousness, your brain waves as being firing at a certain rate, right? Then they end up having a frequency, essentially, the normal alpha brain waves or delta or gamma or theta brain waves, they have sort of a wavelength. So if you can slow your brain frequency down, what you have is all of the things in that brain frequency are simultaneous events in time. So this is all one time epoch. Whereas if you have really fast brain waves, you're breaking time into little pieces. Well, everything that's in the same time epoch is concurrent. And so this is what happens if you go in the zone. When you're going in the zone and you say, how did you get by that guy when you were doing that basketball shot? Well, it's because you're looking, you slowed down time, you're stepping outside of time. And essentially you say, well, it looks like he was moving in slow motion. because you have stepped out where you're now in a concurrent state. It's not possible if you're in time. And so this kind of ideas of the size of the now bubble is important, and you have a more sequential focus the higher your frequency, and a more concurrent focus from a quantum mechanics perspective if you have a slower brainwave frequency. So these are all of this is related to sort of a temporal model and frequency and vibration. So I prefer the term vibration over frequency, because if you have frequency, by definition, you have time and space. That's the only way you can get it. But if you talk about vibration, you're talking about like string theory, and where you don't have space and time yet. You're trying to create space and time. So space and time evolves from these states. And so don't use the term frequency. Don't use the term energy. Use the term information. Don't use the term subtle energy. Use the term prana. Use the term vibration. Use the term to information, rather than the classical terms, which says we're in a classical spacetime. So so part of that is all about redefining the language that we use to think about this in. So essentially, slowing down thoughts, you step out of spacetime. So this is part of the transcendence. Anytime you have a different time frame, you have a different space, and vice versa. Every time you have a different space, you have a different time, because space and time are related. So if you can go to a quantum spacetime, then that's transcendence. And that's what we mean by that, okay? So this is I always love this slide. It's Dilbert, and he says, I created the simulated world made entirely of software. I programmed all the people in the simulation to think they're real people with free will. And the Dogbert says, are they sentient beings? They think they are. And what if they discover their true nature? I programmed the limits to their physics so they can never observe the walls of their reality. For example, they cannot get to the edge of their universe because they can't exceed the speed of light. And they can't find out what they are made of, because to them, everything looks like probability at the quantum level. Wouldn't those limits tip off the smart ones? I coded them not to trust smart people. And this is so funny at so many different levels. I love this slide. And what it ties into this it from bit. It turns out you can't simulate a world inside a computer, because you need something the size of a quantum simulation that runs our world in order to do that. Okay. And so this notion about hyperdimensional space, you've got to have a hyperdimensional space to simulate a hyperdimensional space. And so this is the hyperdimensional simulator. So it's like a quantum version of the matrix. But realize that these dimensions from our space-time perspective are outside this light cone. So you have these space-like states. And this is an important concept I bring up in the book. And it means that you can't do it using classical computer, because things are connected. And by the way, these space-like space states come from E-bits, from entangled bits. So this is, again, all of these concepts are tied together, but this little cartoon triggers all of those concepts in a funny way. So the quantum infrastructure is required to efficiently simulate a quantum universe. And so that's what I say source science is. Source science is this proto physics, bit physics prototype layer that is the sort of the layer that all quantum physics and then all class of physics is built on, and it gives maximum concurrency and maximum information content. So I like to talk about all this source science work as saying, well, look, humans are really intelligent. So what's the difference between real intelligence and artificial intelligence, or infinite intelligence even? I'm using that term too. So AI assumes the mind is a classical brain, and we know all the failures of that, okay? There is no general learning, it's simulating a high dimensional space, and they're just thinking the Turing test, simple Turing tests can do that. They're just not giving it a hard enough Turing test, is my perspective. But real intelligence demonstrate that there's a transcendent mind is quantum-based, and this representation is hyperdimensional, it from bit, all these things we talk about. Even Roger Penrose from the UK, who just got the Nobel Prize this recently, he says the mind is non-computational. So what is that if it's, if that? So the mind taps into this quantum speed up with the space-like states. That's where you get the savant from. It's outside of space-time. So the mind is really the same stuff that the universe is made of. So it represents the source code of the universe. So it can program whatever it wants with intention. So that's an important concept that I bring up in the book as well. And the brain is most likely a 3D antenna, Tiller's term bio bodysuit. And so therefore, real intelligence is more meaningful than AI. And we don't have to worry about computers reaching a singularity where they take over the world and take over our existence, because they will never be able to do it because they're not quantum. So the best thing to do is don't amplify computers, amplify humans, which is the real intelligence aspect of it. And so we talk about that in the book. What does it mean for all of this? At the last couple chapters, the last section of the book is talking about that. So it changes who we think we are because of this transcendence in these hyperdimensional states. It changes who we think we are. We're spiritual beings. We understand our purpose, that meaning, thoughts and meaning exist outside of the quantum mind level. And so you can have arbitrary intelligence. So, be super smart, have a Kundalini awakening. All of these things are possible, knowing that it's not bound by classical physics, and understand how to apply these in your daily life. And so I talk about that in the last, half a dozen chapters in the book. So anyhow, this was a whirlwind introduction to some of the concepts in the book. And there are, again, more slides, more talks out there that goes into more detail if you want to know the detail. Otherwise, just skim through the book and pick up the pieces that you think that you would be interested in learning more about. And with that, I'll turn it back to David.
Thank you very much, Doug. As you say, that was a true whirlwind tour de force as well. Perhaps you could just stop your sharing the screen, and then we
absolutely.
get back to kind of, that's it, great. And I think that probably what a lot of people want to do is to get you to unpack a good deal of that by way of the questions. And so I'm actually going to go straight into a break, just take a 5-minute stretch break to get our thoughts in order in a sort of quantum alignment. And then we'll
quantum neural alignment.
Yeah. Then we'll come back, and I'm sure I was very struck, and we've got Bernard Carr on the call, who's our president, and he's talking about hyperdimensional space, and I'm sure he will have a very interesting question a little later. But you gave us a very, very clear outline of the key concepts, and how with an expanded understanding of science, you can expand the possibilities rather than just brushing them all under the carpet and trying to keep a classical world.
Yeah,
it just doesn't work.
In fact, I don't believe you need to invent anything new. The quantum mechanics these bit physics view of quantum mechanics has all the mechanisms it needs to support these phenomena. So that's
I think that's what I think your presentation has made very clear. So we'll just clear our heads for 5 minutes. So we're back at 29, and then we'll just do a brief presentation of the network, and then we'll get going with our discussion. Okay. Thanks so much.
Okay.
See you in 5 minutes.
Yeah.
Rapidly out of the block is Sarah Knox, who is the first person to kick off the question. Sarah.
Thank you. I enjoyed your talk. It went a little bit fast, so I just have one question. I'm looking forward to reading the book when I have more time. You mentioned hierarchical meaning scales based on the fact that these bit states are proto-dimensional. Can you enlarge on that a little bit? Hierarchical meaning states, please. Can you hear me?
I'm on now. I was muted.
Yeah.
I was muted. Sorry. So yeah, the key thing is, if you have information represented in a classical computer as bits, like on a disk or something like that, they have boundaries around them. They're localized in space and time, right?
Right.
But if you have meaning that's associated in this hyperdimensional space, where it's a point in a high dimensional space, then there's no boundaries. So things that are near it naturally have meaning that are related to them. So they are scalable in a hierarchical sense, that you can add more and more dimensions, and it just means I have a more refined point that has more complexity to it than the other point did.
Okay, got it.
So that's the idea of
that makes sense. Okay,
yeah.
Thanks.
And that was the point that Monroe made. He came up with the term rote. Rote is a definition of a meaning that's built on other rotes. So you have to have sort of this scalable hierarchical, where concepts build on other concepts, right? So a simplest example I can give you is addition is used to make multiplication. But once you have multiplication, you can combine addition and multiplication together
Right.
as though
Makes
they're
complete
at the
sense.
same level of complexity.
Right, because it's hyperdimensional. Got it.
Yeah,
Okay.
exactly.
Yeah,
Good question.
thanks very much indeed, Sarah. So Jean, you'll be coming from a different angle, I think. Just unmute. Yes, you're unmuted.
Yeah, I got unmuted. I can't see the speaker. Anyhow,
We can hear you.
I'm assuming that all of these things that you're talking about are based on actual events and things that have happened. Otherwise, how could you have these ideas? And if so, I mean, it's all based on some kind of study of people's minds. And I'm wondering if you've got to the point where you're looking to see what maximizes access to this kind of level of functioning. Are there pathways that you can discern that we can go into those states? Have we explored how these different, there's a whole variety of different states that you're talking about, and how do they interconnect with each other in actual fact, in actual lived life? Because it's a whole new way of thinking, and I'm just wondering if you've looked into the geography of how it's all holding together in actual life, so that people maybe can get a better idea of getting into this stuff than just sort of meandering around.
Yeah, I mean, part of the complexity, part of the problem with this is it's so complex, you know, and if you're trying to come up with a model that's big enough to include all the behaviors we have, it's like a theory of everything, right? So the problem is you got to get your head around, people would want to get their head around all the aspects of the requirements. I would call those requirements that says, hey, we need to be metaphysical, we need to be intelligent, we need to have meaning. Those things I would call requirements. So on my particular journey, I think your question was about how people can use this in resolving their own journey through all of this.
Yes.
I'll give you an example from my journey. Is every time that I was working on this, the universe would kind of like open a door for me, and it kept opening the doors for 30 years. Okay. And if I just were to tell you the chronology of events that got me to where I wrote the book, it would look like a miracle. After miracle, after miracle, after miracle. And so that to me kind of supports the idea of law of attraction. Law of attraction says that like-minded things are attracted to what you're thinking about, but also that I'm being guided to do this. I mean, I look back at stuff I did 25 years ago or 30 years ago, and it's the same stuff I'm saying now, I just couldn't support it as well. So it's like I had the intuition. So my higher self knows about all this stuff. You can think about it. And if you think about it as Akashic records, we all know all this stuff. It's just that we don't know we know it. So I'm believing that knowing is part of this problem that we're trying to solve, in that how do you know stuff? How it's not just data. Data is a set of data in a computer, but knowing it, you know, for example, one of the things you know, if you say, have you ever been exposed to this idea? And you know that you don't know it. Okay, well, that turns out is a really hard computational problem. You have to search the entire database to find out if you know it or not, right? Of all of your experience through all time, but you know it instantly that you know it, okay? Well, it turns out that's a property of hyperdimensional space. So part of the unintuitiveness of this model is that the model, hyperdimensional states and hyperdimensional spaces lead to unintuitive properties of the space. And that's what the correlative theory work is, and that's what the qubit stuff is with superposition and entanglement. Those three concepts are really kind of, it's hard to get people's head around, but it's worth it, because now you understand yourself better, because you are a quantum computer and you have law of attraction at your disposal, and you have infinite intelligence at your disposal. And as long as you disbelieve that it's possible to do that because you don't have a model for it, then you can't utilize it. So not you in particular, but everybody in general, you know.
So, I mean, I realize it's a huge question, but perhaps what you're saying is just knowing that all of this stuff has been discovered and wanting to get involved with it, that you just sort of step into all of this and go whirling along.
Yeah, absolutely. Absolutely. And the universe will guide you based on your particular journey. It's really your higher self. I say it the universe, but it's really your higher self. It's your soul. You know, every one of us really has something that we wanted. I mean, once you realize, oh, we do survive death, right? So we came here with a purpose. You know, we've all had 100 lifetimes or more, more than that, And so if we all had 100 lifetimes that we've existed already, then we already have this mass experience that we are counting on, and that's your higher self, right? But you can also tap into the Akashic records, which is the sum of all people's experiences, right? So figure out, well, what do you want to learn, and then go for it and go find it. And that's essentially been my path: is go to the Monroe Institute, go take a lucid dreaming class, go and experience it. Because if you don't taste of the divine, I talk about it in the book, if you don't taste the divine, you don't know that it's real. Once you taste the divine, you touch the divine, you open yourself to this. I'm not volunteering to have a near-death experience, but people who do, they are irrevocably changed, because now they know that there's something there that they couldn't have explained and couldn't have expected, and it changes them permanently. So,
well, if you touch the divine, it's going to take you over, lock, stock, and barrel.
Well, you bring it back with you, is what you do.
Well, it tends to get a hold of you, and that's the end of it.
Well, I would say that's a positive thing, not a negative thing.
Absolutely.
Well, that's positive. I mean, it's the end of
good.
It's the end of all of this other junk that you're just putting down.
Yeah.
And you go off into your qubit or whatever, and have a great life with your qubit or whatever.
Thanks very much, Jean. I think this brings in. I gave a lecture in Melbourne, another place in Australia, 10 years ago, called "Synchronicity and the Law of Attraction."
Mm-hmm.
And I reading your material, makes these connections a bit clearer. But I'm sure we've all experienced this kind of phenomenon. And what you're saying is that this is, if you with this intent, that these things simply open up. Yeah,
absolutely. I just had an example the other day where we needed another suitcase. So we were driving down the road to come back from our vacation, and we drove by a garage sale, and the idea came in and says, they probably have an extra suitcase that they're selling at this garage sale. So we turned around and went over there, and they did. So you have to just open yourself up to these little insights that come from your higher self. And you just have to, there's a cop ahead. Oh, slow down, or turn right here. And all of those things are you actually looking into the future. Which is part of this temporal model stuff, presentience and retrocausation stuff. So,
yes, thanks so much, Jeremy. You're next.
Thank you, Doug. Thank you so much. My mind is sort of blown away. I don't understand 99% of what you say, not being either a physicist or a mathematician, and coming from a completely different point as a theologian and a psychotherapist. So I'm interested in what you're saying about the divine. Mm-hmm. But if I've understood you right, your model is based entirely on bits of information, which are binary. Mm-hmm. So it's one thing or other. So my question, to try and open things up a bit, is: does the universe have a right hemisphere?
That's a great question. We always talk about right hemisphere, left hemisphere, right? Logical thinking versus, emotional thinking. But both of those hemispheres have their own meaning, right? Yeah. Logic, right? Emotions have their meaning. If you have a near-death experience, you have deepest joy that you've ever experienced 1,000 times more than you can ever imagine, right? Mm-hmm. And so that can't be chemical, because there's a limit to how much chemical you can pump in your system, right? So you have to have sort of a scalable solution for meaning, and logic is a kind of meaning, and so is emotion is a kind of meaning. So the model here I'm saying is you have to have a model. It's built on the essence of what physics have to offer, what the universe is built on, these proto bits is what I call them, bit physics, and that can give you a scalable meaning system. And that's what this source science model is. It gives you all of these meanings using law of attraction style correlative.
Can I just ask you, what do you mean by meaning? Because hang on, because all of this is terribly abstract.
Absolutely.
Meaning to me is something which uses imagery, metaphor, feeling, connection, is human, divine as well. But all this sort of physics language, it has nothing for me to do with meaning whatsoever. So I want to know what the connection is. And I also would go back to my questions. What does your model not cover? because it seems to me that it is the most hyper-reductionist to physics model of the universe and everything that I've ever come across. You know,
I guess that's a compliment.
All right, but you know, there's nothing left over. So what, you know, you've got this metaphor, if you like, of the universe as a quantum computer or something. Now that's just a metaphor.
Yeah.
What does it not include? Because all metaphors have something left out. And you know, the physics and so forth does wonderful things, and your work is incredibly impressive. And from a physics point of view, I'm sure it makes a lot of sense to those who understand those things. And I've got a sort of overall sense of it, which I can't sort of pin down. I've got your book. I haven't read it yet. I was going to listen to your talk first.
Okay.
You know, so I want to work it through. But what really worries me is, what about everything else? And all the other ways of approaching the mystery of existence? Where do they fit?
Yeah. Well, I try to do that, a lot of that in the book, but I want to go to your question that you started with first, which is the meaning. You know, meaning. What is meaning? You said, you know, you want me to define my term, right?
Yeah.
You want the meaning of meaning.
Yeah.
Right. Okay. So the point is that if you have, I'm just going to use this as an example, just a conversational model. If you have an artificial intelligence that determines that if you're smiling like this, a face, it recognizes the face, it says, oh, he's happy. Do you think the AI that recognizes that you're in the happy state because it's recognizing your facial expressions, do you think it knows what the meaning of happy is?
Of course not. But
of course not. Great.
But you're going down to a very low level.
Yeah, I know. But I'm just using that as a counterexample, is what I'm trying to say.
But you're talking about your higher self. Now, in terms of your model, I have no idea what that could possibly mean. You seem to be referring to a different type of meaning system from what you're talking about.
Right. Exactly right. So my point is, we have to have, and this is the same terminology that Monroe uses, is rotes, because if you're going to have telepathy, you have to have meaning without words, without language, without electromagnetics. So I'm looking for something that can do that. Well, these hyperdimensional spaces using this content addressable memory, these correlative objects, represents a system that can do that job. And it's different than having a simulation of those, which is what we do in AI. It actually has those dimensions. So the difference between a simulated hyperdimensional space and an actual hyperdimensional space, I believe, is the difference between bits on a disk and actual meaning in our mind. In other words, there's no meaning anywhere in the universe except humans project meaning out on everything they see. There is no meaning anywhere else.
What if the universe itself has meaning and humans intuit it or receive it from outside?
I believe that's what I'm trying to explain with this model. Is a rote. If you have this is from the standard remote viewing experiments. They say, I know people who do this. They say, I want to target this target. They get this packet of information back, right? This packet of information pack is the encoded information of what they just requested, but they have to unravel it into time so they can say what the meaning of that remote viewing experience was, right? So that rote represents a primitive meaning, but it's not in any language we know about it.
Yeah.
Swedenborg said that in the 18th century as well. He said that the telepathy, well, obviously the word didn't exist in those days, but it was his thoughts being transferred without language.
Yes, absolutely.
And I think what I think so interesting about your approach, Doug, is that you're taking a radical empiricist approach, as William James would say, the whole range of human experiences, and then you're asking yourself, well, what can actually explain this theoretically? Yes. Whereas a lot of the people that won't look through the telescope, using the Galileo metaphor, they've got their theory already, and so they know what's possible and what's not possible. And so you simply stay within your theory rather than starting from this whole range of experience and then saying, well, what kind of theory do we need that's actually adequate to explain it all?
Mhm. Well, and I would even add to that, David, in the sense that most people don't even look for a model. They're only trying to prove that it exists or not.
Yeah, that's true.
So
Jeremy,
they're not even looking
much.
at the models.
Okay, well, thank you very much, Doug. I look forward to reading your book.
And hopefully that gave you some insight.
I think it's really provocative and interesting. Thank you.
Yeah, great. Thank you. No, this is a good moment, Bernard. With your hyperdimensional.
We do a mind swap here.
Okay. Well, thank you. First of all, Doug, I want to say how great it is to have someone else who's approaching these problems from the point of view of physics, because I've always argued that this new paradigm, which is going to accommodate these sorts of phenomena, mental and spiritual phenomena, has to make some link with physics.
Yeah.
Now, and I do sympathize with Jeremy's remarks, where Jeremy was reacting against being able to reduce everything to physics because it sounds very reductionist. But what I'd like to stress, and maybe I'd echo your own thoughts here, Doug, is that this physics isn't normal physics. I mean, the final physics we're going to have, I call it hyperphysics precisely because it's very different from normal physics. And at least in my vision, this hyperphysics, it sort of does include, if you like, right hemisphere type features. It includes experience as well as experiment, things like that.
Absolutely.
But now, to come on to your own theory, I'm really very excited by your theory because I myself have been pushing what I call a hyperspatial model, which is equivalent, I think, to your hyperdimensional model for many years. And there are many similarities. I mean, I'm invoking many dimensions. My extra dimensions, they sort of correspond to extra time dimensions, and they correspond to different specious presence, which I think corresponds to what you talk about in terms of the now bubbles. I think you've also got different frequencies. So in some sense, your model maps very nicely onto my model. And in some sense, I sometimes even refer my model as invoking a higher dimensional information space.
Absolutely.
So it links in directly. But I've never had a very clear vision of what I mean by a higher dimensional information space. And what's great about your model is that you're obviously able to make that much more precise. And so I have to confess, I've not read your book. So I'm really looking forward to reading it and making contact with you.
Yeah, maybe future discussions more about that.
Absolutely. But I have a conceptual question. And that's to do with the whole question of the relationship between quantum theory and information theory. Because you said that you're not invoking anything new in this approach. And I want to query that because I've always argued that the sort of paradigm one needs has to go beyond straightforward quantum mechanics. And there are various reasons for that, but one reason is that even within physics, we know that we're looking for a final theory which is going to reconcile relativity theory and quantum theory, and that theory must go beyond quantum theory itself. So I've always said that you're not going to get, the new paradigm has to go beyond quantum theory itself. You need some deeper paradigm which underlies both mentality and quantum theory. But now you're speaking about your information theory, so it is just quantum theory. So I want to ask whether you really mean that, because I can understand, I could appreciate having a deeper theory, which is information based. This deeper theory will accommodate quantum mechanics and mentality. But are you saying that information theory itself is simply equivalent to quantum theory, or are you saying your approach is actually a deeper interpretation of quantum theory?
It's a deeper interpretation of quantum theory and says that quantum theory itself can come out of pure bits. And but the other big thing that I want to make sure that you understand, when most people talk about quantum theory, they talk about quantum theory as in embedded in 3D. Right? Even the Schrodinger equation and all of that stuff is all time evolution in space and time of these equations, right? Well, my model, the what I call proto physics, I call it proto means before physics, right? Meta means above, beyond, but proto means before. Well, proto physics, I use that term proto because it's before physics. So if you have bits that exist that are equivalent to the quantum states, they can't put their finger on it because they said it's a probability distribution, right? That's what they say in quantum physics.
Yeah.
But they assume those probability distributions exist inside 3D. That's what the Schrodinger equation is all about, right? I'm saying, no, these bits exist before space and time even. So not only does quantum theory have to come from these bits, but space and time has to come from these bits as well. And so that's the differentiation that I make about how you said, like you said, it's more fundamental that, but it has to be consistent with what we know about entropy and information theory and black holes and quantum mechanics. And so I think it is. In fact, in some of my books, I did my dissertation in 2002, but in 2010, this colleague Mike Manthey and I, we went in and did a model, and there's a paper out there where we did the standard model built on top of this quantum model that I did for my dissertation. Okay, so you can see electrons, you can see protons, you can see all the things that have mass and all the things that are the bosons. And in fact, we predict the dark matter and dark energy states and the Higgs boson. We predict what their geometric algebra equations are. And it gives you some insight. For example, one of the things we found is that there's another neutrino out there because of the symmetry of the space. Okay, there's a fourth one. And physics has been dancing around that for a while. Another thing we figured out is the Higgs boson is four-dimensional. So no wonder we can't see it. It's a four-dimensional thing where a neutrino is a two-dimensional thing. Well, no wonder we can't see that either. Only the other particles are three-dimensional. So if you look at so that is a complexity to look at. So look at that talk I gave about sort of how we get the standard model. And if you need a link, I'll share that link with you.
I'd like that link. But that's really very interesting because, I mean, my own approach says that in some sense you can interpret quantum mechanics in terms of a higher dimensional space, that this higher dimensional paradigm both explains quantum mechanics and explains mentality, if you like, and you're saying,
and space and time. Don't forget space and time.
Well, and space and time. But the point is, this model does go beyond space and time. I mean,
yes, it does. It's outside of space and time.
Yeah. So I find that really fascinating, and I like the way you refer to proto-physics, because to some extent this perhaps helps to answer Andrew's point. I mean, I talk about hyperphysics in the sense that you're going beyond normal, certainly going beyond normal classical physics, and even going beyond other forms of physics. But in some sense, you're using the word proto-physics, but either word is emphasizing the fact that you've got this much more expanded view of physics and indeed of science.
Right.
And that might even make Jeremy a little bit happier.
Yeah, exactly. And remember, these bits are not full-fledged dimensions. They're just little bitty differentiations. They're little, that you can just have a state that's like a quantum state. It's either spin up or spin down, right? But it's independent. It's not represented as matter and energy. So I call it a bit physics, and I call it this proto-bit. That it represents bits in this mathematical framework are their own dimensions. So if you have a 1,000-dimensional space, you can't even represent it, matter of fact, talk about it and get the kind of speed up that you would if you're simulating in a 3-dimensional space. Because you have anisotropic behavior.
To parody Armstrong, you might say that's one small bit for man, but one giant bit for humanity.
Yeah, absolutely. Thank you for that.
Yeah, that's very nice, Bernard. Thank you so much. I'm just going to take a question from Dave Pruitt in the chat here. He says, when one first encounters the thermodynamic concept of entropy, it's foreign because unlike energy, mass, and momentum, entropy is not conserved. In an isolated system, it tends to increase. However, one cannot help but wonder if the entropy increase in the physical universe is balanced by the entropy decrease in the informational universe, so that entropy might actually be conserved in a broad enough frame of reference. Could you comment?
Very interesting.
Yeah, I like that. Well, the key thing is to realize is that most of physics is done inside the 3D framework. Even what we call quantum field theory is really done inside a quantum, the 3D network. So if you take that approach, then you realize that all entropy is about these closed systems that are in 3D. Well, if you look at those experiments that we did with Chiller's experiment with the they essentially were open systems to a higher dimensional space. And I can use this as a simple metaphor to talk about this. If you have a two-dimensional space like flat world, and you try to create a knot in it, you can't, because the knot has to have this third dimension to create the loop. So in order to create a knot, you have to have a three-dimensional space. So, and then if you have a four-dimensional space, that knot pulls apart because there's another dimension. It's like a magician's noose. It just pulls apart because there's an extra dimension for it to come apart on. Okay. So once you realize that the number of dimensions of the space determines the properties of the space, right? Then you realize that entropy is that way too. It's like a four-dimensional. You can cheat because it's always open. That's why these thought experiments, PK experiments, work, because you can always get in a back door to any physics because it's only three-dimensional. So,
okay, thank you, Susan.
Yeah, hi, thank you, Doug. Thank you. This is very intriguing, and I've read concepts and about physics before, and I'm very intrigued with these connections that you're making. And there's two statements that you made. One is a quote, I think, one was a quote from John Wheeler, but the other thing that you said, and I think it's from you, I'm not sure someone quoted it, but you said in your presentation, beingness is the noun and verb at the same time.
Yeah.
And that really caught my philosophical side of me, because I think that is so much true in my meditations and other things. And then John Wheeler, who said, time is what prevents everything from happening at once. So these are just, to me, like these brilliant statements. But I wanted to ask you, perhaps, and not really a question, but those types of statements or observations that you bring in, is this attempt to make this link between your study and quantum physics and other dimensions into what many of us do actually experience on some intuitive level. And I don't know if you just have more to say about that, but I thought it was wonderful how you brought into your study and all of this physics, how you brought that thought into it. And I guess I'd either like to hear more about it. Maybe there's some more in your book about it, but are there additional linkages like that? Okay, great.
There is a lot of that stuff. I mean, the front half of the book is trying to talk about tiptoe through the science part of it, and it might be kind of deep for some people, but just skip through that. And then the next part, it says, well, what does it mean? And then it says, the third part is, well, what does it mean for the future, kind of thing. And so I talk, at least a half of the book is about, well, how can we apply this and what does it mean? But the key is that these concepts are limited by what language we use to talk about them.
Yes.
Okay. So I'm trying to redefine and carefully define the language, like use the word prana rather than subtle energy. Use the word where I'm talking about lucidity and infinite intelligence rather than talking about consciousness, because consciousness, you can't say much about consciousness, right? So these are more, so the same thing is true for verb noun. How, I would like to come up with a better name for verb noun, but I figured this one emphasized the verb before the noun, because on our Western society, we emphasize the noun over the verb. Where Indian languages, like American Indian languages, they're verb dominant. Okay, so it turns out if you ever listen to a name of some Indian's name, American Indian's name, it sounds like this long phrase. Well, what it is, it's a bunch of verbs strapped together, and that's quantum computing. It turns out they did a study, and people who were doing remote studying Native American languages, those people understand quantum mechanics better than people who are noun-centric in their language, because the verbs are essentially a bunch of quantum operations that are combined together into one thing, and that's quantum computing.
Right, and so in a simplistic form, it's more the process, right, versus the noun, right? It's this continual process and unwinding, as opposed to an arrival.
You can use it for action or being.
Yes, very good. Thank you very much. Excellent.
Yes, thank you very much. David Bohm talked about the Rio mode, didn't he? And he was, and we have this propositional logic which we've inherited either or from Aristotle, where as you say, the emphasis on the subject and the predicate, and what links the subject and the predicate is just not given any emphasis.
Yeah.
Anyway, Peter, your question will be coming from a different angle, I think.
My question is coming from quite a different angle. Thank you so much for your talk. I must get your book and read it because there was such a lot in it. Obviously, one can't at first hearing follow it. But I want to try and tie you down to some of the concepts you were talking about. You were talking about brain frequency. And you were saying that the slower the frequency, in some way, this in fact gave the brain more intelligence, or you didn't put it that way, but that was what I understand. Mm-hmm. So can you talk to me just for a bit about brain frequency and what you are implying from that?
Yeah, that's a great question. We, like I said, most humans, and because most of us are Westerners, right? We think about everything inside space-time, right? And so we think of everything as a frequency because frequency is defined by space parameters and time parameters, right? So the problem is if our mind is outside of space-time, how do we unleash it, kind of set it free? And the way to do that is the kind of thing we do with meditation or dreaming, is we slow the brain frequency down so that essentially we escape the brain. And in fact, you have to do this every night when you dream, because if you don't, if you keep yourself from dreaming, you're essentially keeping yourself in entropy, and your mind resists that over time. And it'll start dreaming instantly as soon as you go to sleep because you haven't got enough dreaming time, right? REM time. So realize that dreaming isn't about garbage collection. Dreaming is about releasing from entropy. And the way it does it is it releases from space-time. You're not hooked to the brain anymore. And now you violate the laws of physics because you're in a hyperdimensional space that doesn't have entropy, doesn't have matter, doesn't have energy, doesn't have space, and doesn't have time. It has this hyperdimensional space-time where the only time that's there is change. There is no time thing. So you can have a dream that's an epic dream that lasts for years, and you can do it all in one night, right? Time isn't related to that, okay? And you can read precognitive time. So time isn't related to all of this, okay? So I'm just trying to make sure that people just decouple the concepts that were so embedded that everything's in space-time. We have to say, well, what does it mean if we're not in space-time? And what does that look like? And what does it feel like? And what is the mechanism that allows that? That's what I'm trying to get using this kind of vocabulary. Hopefully that answered your question.
Yes, it's very exciting, but it still leaves me with one or two problems. My first problem is that if you look at the literature that we have, at the moment about how the brain works, transcendent states, the very high, deep transcendent states aren't slow. They're extremely fast. And some of the people who have the widest states have the fastest brain waves. Now, that doesn't go with what you were saying, because to get to escape the brain, what I had to do was to slow it. It doesn't look like that.
Okay. And I know that there's research about people who are like advanced meditators, monks and things like that. And what they find is that since the brain isn't being driven by the mind anymore, the brain is running free running. And so all the frequencies are there. So again, it's about decoupling. It's just how you have to interpret the model, which is if you're decoupling from the brain, what does the brain look like once you've decoupled? Okay, and there's a bunch of research that could be done on all of those different aspects of it. Yeah. Same thing with psychedelics, right? If you have psychedelics or anesthesia, what happens? Okay, so those are all examples of when you're decoupled from your brain. Like lucid dreaming is the good example. I mean, if you're lucid dreaming and you're looking at a ping pong game in your lucid dream, your eyes follow you, follow the ping pong game. That's how they were able to signal. For lucid dreamers, for testing, they used the ping pong match to signal back to the real world. Their eyes were still connected to, even though they were in the lucid dream. Okay, so how far do you have to get out where your brain is not paying attention to your consciousness anymore? Monroe talked about that in his books. The dream research talks about that. These meditation studies. So I'm just using this as a model where, if you're in the zone, all the research about being in the zone, essentially people say, well, it's like the entire thing went in slow motion. Well, there's nothing you can do in physics to have everything be in slow motion unless you're stepping out of time, right? And because if you were accelerating, everything would be just the opposite. Everything else would look fast compared to you because acceleration. So essentially, you're pushing the universe away from you. It's the inverse relativity. In order for you to be faster than everything in the physical world, you have to be orthogonal to the 3 dimensions of our physical universe, and you have to push the entire universe away from us. So it's inverse relativity, and then you can perceive the universe as being fast. You're faster than the rest of the universe because it's slower than you. The rest of the universe is in time dilation, and you're not. So
really interesting.
Yeah,
yeah.
That's fascinating. Thank you. And can I ask you just one more question? And this is about the chakras and the energy that you were talking about, circulation of energy. Can you say a little bit more about that?
Yeah, if you look at the chakras, you normally see this. In fact, kind of behind me, there is a chakra map up on my wall back here. You see this red, orange, yellow, green, indigo, blue, violet,
and
right?
so
These petals, right? What are the low chakras? They have very few petals. And when you go up to the next chakra, what does it have? More petals, and then more petals, and then more petals, and then more petals. Those petals are a metaphor for complexity. They're not a complexity metaphor for frequency. So they represent more information states rather than higher frequencies. So anytime anyone talks about consciousness, they talk about frequency, they're in the wrong language domain to talk about it.
Wrong.
So I'm just using the example of that slowing the brain down as a way of starting people to think about where you have to stop using the reference frame of frequency. And chakras is an example. You can't talk about higher frequency chakras. Doesn't make sense. It's higher complexity chakras. And your crown chakra has much more complexity because it's in a higher domain and has much more dimensions associated with it than the lower chakras.
That's a wonderful orthogonal.
Thank you very much.
Yeah.
Hopefully that helps.
Terrific. Very much enjoy that.
Thanks so much. We'll go to Sarah, and then I'm going to bring in Patrick Wynne-Jones, who's been in.
Okay, I'll try and make this quick because I know we're short on time, but it's very interesting that there's a book by Thomas and Birgitte Görnitz. Have you heard of them?
No, I'm not.
I'm going to show it because it's so similar to a lot of things you're saying.
That's cute.
If you read German, he's a physicist and she's a psychologist. And they even use a similar concept to your proto-dimensional. They call it the prototypesis. It's a very easy to read book, but the interesting thing about it for me was the concept of wholeness. So they very much take the approach from Bohm and from Jung, and they talk about, for instance, that you can have ambivalent feelings because of entanglement. So it's not either or, it's this and that. So I wanted to show everyone, if you read German, it's really, I don't know, von der Quantenphysik zum Bewusstsein. It's really easy to read, and I mean it's it's written not for physicists. So just to
so again, I mean you were giving me a quick summary, and I'm not holding you to it, but my point is we have to be careful about our language. And that's what I try to do very carefully in the book, is really clarify the language, okay? And you just use that they said that they talked about entanglement as a way of combining these states. Well, it turns out entanglement is a specific example of a higher dimensional version of superposition. But what you're really talking about is superposition first as this phase angle, okay? And that same phase angle shows up in neural computing with these thought vectors. So entanglement adds a specific new thing for it. It's a higher dimensional version of it where they're coupled. So for example, I've met people where the first time I met them, we both knew we were being telepathic with each other. How is that possible? It's like we were connected at some level. So I would call that an entanglement because we were both sharing the same thought vectors at the same time, and we both knew what they meant.
Yeah, I see what you're saying.
And in fact, if you look at a lot of the chakras and the like the Akashic field, right? They say there's these Akka chords, right? Well, they say every time that you meet anybody, you're connecting with the Akka chord of that person. So you actually, their energy state and your energy state are probably entangled. Okay. And so in fact, there's these rituals that you can do as part of Hermetics where you can go and cut all the Akka cords so they stop draining you. So you can get rid of all the people that you don't want in your life anymore and have them stop draining you. Okay, because your Akka cords are connected to everybody. You're too wide open. So there's once you understand that there's this model here, you can say I can apply it here and here and here and here and here, and you can look at a lot of esoteric traditions and see where they're coming from. So
yeah, so that was my sloppiness. But one of the takeaways I had from it was the fact that entanglement is for telepathy and all kinds of things. So you said it. So yeah,
absolutely. So I wanted to make, and again, try to use as precise the language as you can, because it affects your own thinking, right? NLP teaches you if somebody speaks something, it's a reflection of what they say. And if they say it, it affects their thinking. So you want to be aware of that thinking, talking loop that you do with yourself, because that's all the self-talk that keeps us stuck where we are. So I find myself doing the same thing. Don't use the word but.
There's a huge glossary, incidentally, in the book with all sorts of new words like correlatism and rotes, which you won't probably have heard of either. Yeah. So Patrick, maybe you can switch yourself on and ask your question. This is Patrick Wynne Jones. Can you find him, Andrew? Otherwise, I'll try and do this.
Yes, I've found him. Patrick, if you can unmute yourself now, that'd be great.
There we go. Okay, go, Dick.
Great.
My name is actually Dick Benson Giles, and I've trespassed on Patrick's territory because I couldn't manage somehow to book myself in this evening, so I've taken the liberty of trespassing. But I, in a sense, I represent the very ordinary man in the street who has very ordinary questions, which are still tantalizingly puzzling. I mean, all this stuff we've been heard about tonight is very meaningful. I accept that. I'm not disparaging in the least. But it does, in order to explain itself to other people, it has to use very, very complex language, which the ordinary man in the street just possibly can't understand. I mean, in the end, presumably, we're all trying to understand what on earth we're here for, what on earth it's all about. And if you do that, there are various ways of doing it, but the ordinary man in the street has marriages, death, births, children, divorces, miseries, unhappinesses, happinesses. They don't really relate much to quantum physics or anything else. That's not to disparage research into quantum physics or our current remarkable speaker tonight. But one does wonder, does this help me understand why I'm here? Is there, the human mind does tend to want to know the whys of life and the whys of death. Why are we here? What is this all about? And you'll not necessarily get close to an answer by quantum physics, because the thing, involves your emotions and your heart as well as your mind, if you like. And I find it all very difficult. I mean, I'm a writer, a published author, and I think I'm a fairly intelligent person with a fairly wide vocabulary of the English language. And yet I found some of the stuff tonight, which had to be used by the speaker and the writer clearly, very complex and very difficult. So if you can explain to me anything remotely near why
I would love
I'd be delighted.
I would love to. So okay, there's probably everybody on this call drives a car or has driven a car, or at least is aware of cars, right? So if somebody was saying, how much knowledge do you have about cars? You say, well, I don't know how to build one. I don't know how to fix it. I don't know how to design it. But everybody knows about automatic transmissions, about the engine, about internal combustion, about anti-lock brakes, about gasoline, about fuel, there's 100 concepts that we all know to a level of understanding about cars. And we don't have to be good at any of them to drive a car. Right? So all I'm trying to do with this book is define a bunch of terms that are related to the concept, like internal combustion engine. Well, do you think you need to know about internal combustion engine to drive a car? No, but when you run out of gas, you might want to care about that, right? That, it's not working because I didn't put gas in it, right? Because it needs an internal combustion engine, or I need to plug the battery in to charge it up, right? I need to know about energy. So the point is that the mind, if our mind is really a quantum mind, then we need to have enough conceptual layering of language about it so that we change the way we think about who we are, so that we can do something with it rather than just doing it the way we've always been doing it. And so that's what I tried to do in the book. And hopefully that metaphor explain why you really need to know about superposition. You really need to know about entanglement. You really need to know that,
I agree. Yeah,
that there's these things out there, entropy, and that you have something that's before space and time. These are concepts you don't need to know the math for, but you would be useful to have a concept about who you are by knowing that in the same way that you know about your cars. So.
Yes, and I think it's also, I mean, from a sort of philosophy of science angle, what you're talking about here is what the medieval theologians called adequacy or adequatio, that your theory has to be adequate to what it's explaining.
Yes.
And the critique in the Galileo Commission report is that the theories we've got are not adequate to explain the range of human experience.
Yes.
So long you come and Bill and others and Bernard and with expanded theories that can actually accommodate these phenomena, and obviously you're going to have to expand your concepts and your language and be very precise about some of these terms. I mean, as you said yourself, you know, you for reasons you've given, you need to use a word like vibration rather than frequency, or it's better to use prana, which is a more neutral word, than subtle energy.
Absolutely.
And so on. And so I think that there's a certain level of precision that is required, but at the same time, the actual knowing that you've been talking about this evening is intuitive.
You
know, so
I'm just coaxing your mind into the space where you already know this. So
yeah. So we got two more questions, Alex and then Hardin.
Hello, it's Alex.
Hey, Alex.
And we can't see you, or
yes, I'm sitting
you're in
outside
hyperdimensional space.
I'm sitting outside in the dark, so there's no point.
Oh, okay. There's nothing to see, right?
Thank you for that lovely talk, and I'm definitely going to read the book. My interest, Doug, is from a time perspective. I've personally experienced time slowing down around me, time slowing down. And I had to be, I occasionally used to fall into trances, and someone, military or whatever, had to come up and shut me down because I was in the middle of London and literally everything started to go staccato. So everyone with mobile phones and everything, it was like a time field. And I've also experienced what I can only call, in a trance state, parallel thought, where there's layers of thinking on top of each other. But there's many experiences that everyone's had, and they're all different and personal or not personal. And I do like transpersonal thought. But Doug, what I wanted to ask or inquire about was a concept that you talk about, dimensionality in quantum computing. It's an idea I've had for about a decade, and it regards entanglement. At the moment, people use quantum entanglement in distance for, let's say, the latest GPS satellites that the Chinese are using. Mine idea is to have quantum entanglement in time, and I call it a zero-time chip, and it bridges classical and quantum computing. And what it is simply to self-entangle a system through time. So when a computation is processed, it can send back to itself its own answer. And I think because that then makes redundant the processing in the first place, it is actually dimensional computing. Is that something I could write an email to you about?
Yeah, you're welcome to write it. I've looked at this stuff too, with exactly that mindset. You know, it turns out if you take a bunch of random qubits and you measure them with some arbitrary random thing, normally you'd expect to get randomness out of it. But if you do the same two codes that you're using and the same two codes that you're measuring, repeatedly, you actually get information out of it. This is correlative theory. And I have a patent out there that talks about that. And so the question is so if you can go find that patent out there about that, and it shows that you can get something useful out of pure randomness if you combine it in a higher dimensional space. The question is, if you do the same thing with E-bits should be a higher dimensional version of qubits. So why doesn't it work there too, which would allow you to do exactly what you said, send a signal through time? And I haven't been able to figure out how to do that yet. And I don't know if just because I'm modeling it wrong or not.
Unfortunately, Doug, I get into trouble a lot because of my telepathy with the TV and the past.
Oh, okay.
So I've had many anomalies that I've created and paradoxes because I'm watching, and by mistake I might start synchronizing with the person talking. For instance, when you're talking about programmed water, I had a DVD of Masaru Emoto, and we both came up with the same idea at the time of reconfiguring MRI scanners. It was something to do with healing, but it was just sometimes it's positive, but changing the past is absolutely possible, and it's problematic. But I'll send you an email, and maybe it'll be of interest.
Yeah, Alex, it was good that you stood out. You said something, because everybody has a superpower, even though they might not be aware of it, and they have multiple superpowers. So if you already know what your superpower is, great. My superpower is thinking about hyperdimensional spaces and our 8 temporal models. So I'm going to share that with you all right now. That's how I wrote this book, is because my superpower is my higher self keeps whispering in my ear about all that stuff, and it's self-fulfilling prophecy kind of thing.
Exactly what I'm interested in. Thank you very much.
Great.
Yeah, fascinating. Thank you so much. Hardin, nice to see you. What's your point or question?
Oh, very good to see you too. This is fascinating stuff, and I've got lots of questions, but I'll boil it down to one. There's this notion of directed intention. I think it's one of the examples is where people can voluntarily flip the interpretation of a visual paradox, like a Necker cube or something like that. So you're describing these spaces of meaning and so on, but at the same time, we can direct where, you talk about even the remote viewer decides to look at something. Well, that property of deciding where to focus within these spaces, that property of consciousness or self or whatever it is, is there any way, or do you have any thoughts on how that connects with your model? Because your model presents us with this wonderfully rich space, but how are we navigating within it?
Yeah, absolutely right. There's a whole bunch of predictions. Remember I said these models, should they make predictions? So I could list a long 20 items of things, of predictions we could make about quantum models, quantum computing. One of the experiments I want to go do is go implement Dean Radin's experiment. Instead of using superposition, I want to use entanglement. I also want to do this Dean Radin's experiment instead of using double slit experiment, to actually use a quantum computer, IBM's quantum computer, and go run an experiment where I'm using an off-the-shelf quantum computer and showing that the mind can influence it. Because IBM would pay attention, because now all of a sudden their quantum computers are not independent of the thoughts of the people who are looking at them. They would care about that, right? So there's a bunch of predictions we can make, including the kinds of predictions that the Tiller Foundation does, where they showed that autistic kids, when they signed up for broadcast, that they would change their energy of the autistic child was measurable on a measurable scale, that they would do it before test and after test, that they could change the behavior of these kids on an objective measure by doing intention host device experiments with these autistic kids. And I know several people now who are broadcasting love to the whole world using these devices all the time. So the point is, what else could we do with it? So there's a whole bunch of experiments that could be done, and things to help people. Maybe there's an anti-Republican frequency or something like that, or vibration, or one that's not, one that you're more hopeful about the future rather than not so hopeful about the future.
We need some intention in that direction.
Yeah. So anyhow, so the point is that there's a bunch of experiments, and your example was triggered that essentially you're proposing other experiments, and if you have those kinds of experiments, write me and we'll help you figure out how you would do those experiments.
Okay. I was also wondering, what is the property? I'm not sure whether you're picking me up here.
Yeah, I can hear you. Go ahead.
Yeah. Well, there's something about the self which is able to change its focus within this space of meaning. Let's put it like that. So that still seems to be sitting at one layer of mystery back from what you're disclosing.
Remote viewing shows that anybody can point to any abstract remote viewing experiments. They have shown that you can take an arbitrary coordinate system and people can target in on it.
Yeah.
So somehow people have the ability to use abstract coordinates. Well, that's the meaning. It turns out in the spiritual world, it's called the name of the concept. And that name is the address of the concept.
Yeah.
And that comes right out of correlative
yeah.
theory.
Yeah. What is it that is doing that?
It's your mind's eye.
Guessing. Yeah.
That is this little hyperdimensional spaceship that is essentially the focus of attention. Can be at a point in a high dimensional space, but can be concurrent. So it can actually be in multiple hyperdimensional space points at one time. And you can think of that as a bigger single hyperdimensional point. And so this is how you do concurrent thinking. And you can do concurrent meditation this way too. So
the self is some kind of more complex structure in higher dimensional space.
Yes. It's the assemblage point in Carlos Castaneda's perspective. So,
and I think it also thank you, Hardin. That makes sense also of this often reported phenomenon in higher dimensions. That as soon as I thought of somewhere, I was there.
Yeah, absolutely.
In other words, you find this in a number of extremely articulate accounts, but it's a pattern. Either there's a collapse of space or collapse of time, depending on which way you're looking at it. And one of the most interesting experiences that people can look up is by a man called Sir Auckland Geddes. And he gave this paper to the Edinburgh Royal College of Physicians called A View from the Grandstand in 1935 or 36, where he gave an account of an experience which he said had happened to a friend of his, but later on he admitted that it actually happened to him. And he had an NDE, but with these kind of extraordinary space-time accounts, extremely intelligent man describing this with great precision. So it's in my book Survival, one virtual. Anyway, Doug, I'd like to thank you very much for an incredibly stimulating tour down the rabbit hole, as it were. And what I think you've done for us is really opened up very exciting vistas of possibilities, and I love this liberating spirit that you have. Let's try and have a Procrustean fitting in what we already know. Let's intuit, expand our idea of what's possible, and then find out what we already know in terms of theoretical models that actually make sense of all that, and then adapt our language at the same time, so we expand and make our language more subtle.
Yeah, absolutely.
Fantastic. And I think if you want a deep dive, as many people have said, you need to study the book and go to Doug's website. And I've got probably a dozen hours of other videos out there already.
Yeah, right. Various levels of detail.
Plenty more homework. And I think what we might also do is invite you to speak within our kind of physics interest group. So that would be interesting to get into some more technical detail. Just as a final announcement, somebody sent me a message saying they're having problems booking for my webinars, my Quest for Wisdom webinars this weekend, which are on www.davidlorimer.co.uk. And I'm speaking about Albert Schweitzer and Dag Hammarskjöld this weekend. And so if anybody's having problems and has tried to book, I was wondering how, after I sent out an email earlier today, I've had no bookings at all. So it could be that Eventbrite is up the spout, as well as our own website booking system, which I hope is going to come back online. So if anybody is having a problem, then just get hold of me personally. So Doug, thank you so much for sharing that. And I think we'll revisit some of these themes and get you involved in some of our other activity.
That'd be great.
So
this is a great group. I was really looking forward to it. This is an August group with really you guys really know your stuff in this area, especially you, David. I mean, I'm really impressed with how much you read every year and all of that you do for this group. So thank you for that as well. So continuous process. Yeah. Well, Andrew, thanks for the technical backup and all our support team. Thanks everyone for coming. And you might need to go and have an unwind before going to sleep if you're in my kind of hemisphere. Otherwise, I think my mind's going to be racing too hard. So good night, everyone, and see you all very soon. Thank you again.
Thank you again.
Yeah.
Thanks, everyone. You can unmute yourselves quickly if you'd like to say a quick goodbye, and thank you to Doug.
Bye. Thank you so much.
Thank you, Doug, very much.
Bye, Doug.
Thank you. Goodbye. Thank you.
Bye.
Fabulous talk. Thank you very much.
Yeah, fascinating.
Thank you.
And thank you, David Lorimer, too.
Yeah.
Yes. Yes.